I came across this inquiry idea from Kai Kitchen on Twitter. Imagine our student can make the discovery about which location in the school is best to place a solar panel. They would do so by placing different microbit at different locations and having the microbit send in the data through radio function to a central microbit, which then logged all the data for later analysis. This is quite a nice idea. Please see the link in the description of this video. Let me show you how I have approached this idea. First, you go to MakeCode. I have that open already. This is the original receiver code from Kyle. So in order to make two microbit communicate over radio function, we need to have a sender code and a receiver code. So this is the receiver code, and I work backward to find out what the sender code should be for this project. So on start, we specify the radio group. It could be any number from 0 to 255. I chose 7. And for quick identification purposes, I write R for receiver. This radio group is like a channel for a walkie-talkie. Only those microbits belong to the same radio group will be able to communicate with each other. Next, we will need to make some variables. For example, I go to the variable and you notice that there are a few variables that are made. Light 1 represent the data for light sensor coming from microbit sender number 1 and so forth. And this name variable is just a general bin so that we can specify the name for different microbit when we write our if statement. So in radio, you will need to drag out the on radio receive button, and you see that it is in the form of a name value pair. This block, the whole purpose is allowing us to label the incoming data, because if all the data that are coming in are all numbers, we will have a very hard time differentiating what number coming from which microbit. The show string block that you see here, this look like a number, but it's actually not a number. It's actually a string. It's represent basically if data, light sensor data is coming from microbit 1, 2, 3 or not. So you drag out the show string from basic, which is here, and then you're going to go down to advanced and choose a text, and you would drag out this bubble and put that into the bubble of the show string block. And you can type in 1. That's why you see the quotation mark. It is not a number. Probably I should have typed S1, S2, S3, but this is the original code, so I keep it the way it is. Now let's look at the serial write value. This is the name, and this is the value. So this block allows streaming of the recorded data to the serial port of our computer. And the receiver is therefore tethered to your computer. The recorded data appear as a text output string in the form of a name and a value together. So the name and the value are separated by a colon. So for example, light 1, colon 255, telling me that microbit number 1 is sending in the data for light intensity to be 255. And I know it's coming from microbit number 1 because of the label light 1. This way, we can specify to log a unique identifier for each microbit data. And it's also helpful when we collect multiple types of data like temperature or sound in addition to light when it's get more complicated. I find a helpful feature on MakeCode microbit is that when you're in doubt about the function of a certain block, I can just click on that block and it will be highlighted in yellow. And then I right click, I go to help. So there'll be a window pop up and I will be able to read more about that particular block or function. So if the name of the incoming data is light 1, then stream the data accordingly. Let's pause and look at the sender code to understand where the nature of the data coming in. So I have the sender code ready to go. So you will see that on start, the radio group is set to be the same as the receiver. And to identify this as sender number 1, I write string S1. Under forever block, I set the variable light1 to pull the data, pull the input from the light data sensor that built in the microbit number 1. And then when I send data as a name value pair over the radio, I need to go to radio again and radio send value and number. And so that's what you see here. I label the data light 1 and the variable is basically pulling data from the input of light level. The toggle feature here that I put in allow me to see that whenever the value pair data is being sent, the microbit will show a bling in that coordinations, allowing me to see quickly, okay, my microbit is working and sending data over radio function. All right, so now we go back to here. The radio send light 1 equal light 1 right there. Tell us this is the name of the data coming in, light 1, and the value will be drawn from that variable that we set, which then in turn draw from the light level input of microbit number 1 as the sender. So then each sender microbit will have a similar program to this one, but different identifier. So this one is my sender number 2, will get the string S2, and so forth. I wish you success in trying this out with your students. My next wondering is that how do we make the code more efficient if we have, like, for example, 20 microbits? How do we prevent ourselves from writing 19 different if statement and loading, 20 codes for 20 different sender microbits? Please kindly share if you know how to do that. Plug in the USB, flash the code from the receiver onto the microbit, which is collecting data right now. Number 1 tell us that the data coming from the microbit sender number 1, number 2 from the other microbit. This sender, so the toggle feature, which is the light spot right there, allow us to know that, hey, it's actively sending data. This is sender number 1. And you can plug in the battery pack and place that at a location that the student desire to collect data. I have already flashed the code onto respective microbit, and this is the receiver, the sender microbit number 1. This is the identifier. Toggle feature, very helpful. And different microbit, you would have to load a unique program onto it, and doesn't matter how many microbit you have, you just load accordingly. And so now let's go back to our receiver collecting data right now. So there's a bit of a lag for data collection. So right now you see that it's actively register the data. I'm just gonna cover one of the microbit and see how the data respond. So immediately light number 2, which is microbit number 2, is plummeted to 0. So we see that data accordingly. It is now time we can stop the data collection and just download the file. And there you go.